In this video, we're going to discuss dimensions of quantities. And by the end of this video, you should be able to confidently solve questions relating to dimension. You should be able to deduce dimensions of a given equation. You should also be able to derive equation using dimension, and should be able to prove the correctness of an equation using dimension. So I'm going to take you through step by step on how to do it. So let's get started. In dimension analysis, three quantities are key. These quantities are the mass, the time, and the length. The mass, the dimension is m, just the first letter, written in capital letter, and the unit is in kilograms. For time, the dimension is t, just the first letter, capital letters, SI unit is seconds. Then the length, the dimension is L, SI unit is in meters. All right, let's begin with these examples here. Example 1 says deduce the dimensions of velocity. So let's begin with velocity. That is A. Velocity is change in displacement over time. So we're going to write displacement over time. Now, what is the dimension of displacement? Displacement will also have the dimension of length because it's still a measure of separation between 2 points. So we'll still go with L for displacement. All of our dimension of time is T. So we'll have L over T, which gives us LT minus 1 when this T goes up. Of course, it has power of 1 here. When it goes up, it becomes LT to the power of minus 1. Next is acceleration. So acceleration is change in velocity over time. So we're going to write velocity over time. What is the dimension of velocity? We've gotten it here as LT minus 1 then divided by t because of this time. Now we have number of the same base dividing, and indices says we should subtract the power of the denominator from that of the numerator. So we're going to write LT minus 1 again. We subtract this from this. This will give us LT minus 2, and that is the dimension of acceleration. So next is that of force. That is the C part of it. Force, as we know, is mass multiplied by acceleration. So we're going to substitute. What's the dimension of mass? Mass is m multiply. What's the dimension of acceleration? LT to power of negative 2. LT minus 2. This will give us MLT minus 2, and that is for force. Next is pressure. That is the part of it. Pressure. Pressure is force acting per unit area. So pressure is force over area, and dimension of force, we have gotten it as ML T minus 2. Then upon dimension of area, area is length times length, which is going to be L squared for area. That's length times length or length times breadth. Either way, it will give you L squared. So by indices, we have L here up and L squared down. So we're going to subtract these two from this one, and that gives us ML power 1 minus 2, then T to power minus 2, giving us ML inverse, okay, then T minus 2. That is 1 minus 2, giving us minus 1, and we have this. So that is the dimension of pressure. So what's in dimension of pressure? We'll continue with work, power, and impulse. The dimension of work, all right? Work, that is E. Work is a product of force and distance moved by the force in the direction of the force. So this is going to be force multiplied by distance. All right. Now recall that we've gotten the dimension of force as MLT minus 2. And it goes to times the dimension of distance is still going to be L because distance is a measure of separation between 2 points. So that is L, that's power 1. We have L again here. So this will give us ML squared T minus 2. This L times this L gives us L squared, then T to power minus 2. So this is the dimension of work. Next is power. That is F. All right. Power is work done per time or energy over time. So power is work over time. We have the dimension of work as ml squared t minus 2, then all over what? T, because of this time here, to power 1. Again, we apply the law of indices. We have t here, we have t here, and they are dividing, so their power will be subtracted in this fashion. So the dimension of power will be m l squared t minus 2 minus 1. That will be m l squared t to minus 3. That's the dimension of power. Then lastly, impulse. Impulse. That is the G part of it. Impulse is a product of force and time, all right? Or change in momentum. So let's go with force and time. The dimension of force is ml t minus 2 multiplied by time, that is t. And this gives us, this is t to power 1. This gives us ml t by indices. Number of the same base multiply, we add their powers. This is minus 2 plus 1. So this gives us ml t minus 1. And this is the dimension of momentum because impulse and momentum have the same dimension.